pictures, and comments on Instagram, Twitter, Slack. I uploaded some of the presentations of yesterday to the shared calendar that you find on the website, so you can download it there. They're not all presentations uploaded yet, so also the speakers that are here, please share your presentations with us if you would like to give access to the students. Okay, today's program, I quickly switch. So we're going to start right away with two different streams of hands-on classes. In here, we're going to have EtherRisk, going to present the implementation of token payments for decentralized insurance, and then staking in the second session from 9:45 to 10:30. We also have IoT architectures and introduction to IoT protocols, which is in the other room on the E floor. We'll go down together for the ones that are interested in this class. Please follow Mark down to the room just after this introduction. In principle, there is a coffee break scheduled in the morning, which is not on my calendar here. Let me check what happened with that. Okay, it seems like it's not here anymore, but this coffee break should be between 10:30 and 11. So the teachers, we will come to the room and ask whether you are already done and whether we could have a short coffee break before switching the classes. So sorry, it might be between 10 and 10:30 because then the new classes start at 10:30. In here, the Ethereum Smart Contract Meets Web Front-End class that is taught by Sebastian again. Then afterwards we're having lunch. It continues with security and smart contracts before we go a little bit more into AI-powered prediction markets, our decentralized smart cities and smart grids workshop. You find some more information about these workshops also on the Slack channel. Evangelos has posted a few information about the decentralized smart cities workshop. This is also very well suited for people that don't have a lot of experience with coding, for example. Then there's another coffee break in the afternoon before we go into the hack introduction. And this is really important, so please make sure that you're all here at 4:30 again, because there we're going to talk about how you set up the groups for the hackathon, what you need to submit, and all the rules and procedures. There are not so many rules, but a few of them. It also regarding how to put together your working groups. You're not going to be designated to a certain working group. You have to find your own teammates during the team building session, which is really important for you to know, because this is also a process that we want you to go through. This is not something that we help you with. This is something where you need to find your right mate. You want to work together for the rest of the week. Please also make sure by now that you put your ticks on the card that you got yesterday, your name tag, where you can indicate what your code skill level is like and also what your interests are. Then we have the official challenges introduced by EWC and UBS and also Future ICT2. Then we have a team building stage where we have different rooms where the challenges are going to be, let's say, a bit more introduced, where you can ask your questions, where you can discuss your ideas and also find your group partners. In here, we're going to have the EWC challenges. We're going to have a room for Future ICT2, one for UBS, and one for the open challenge category, where you can also go into the challenge that we heard about yesterday. And then last but not least, tonight we are having the BIOTS party. at Ambosrampe. This is pretty close to the main station, just behind it. We're going to walk there together from here. So you don't need to find it yourself, and so you can get all the drinks like beers and the wine and soft drinks and some food there. It's all offered by our sponsors. Okay, then I would say, is there any question right now? Did you something you didn't understand and this is really important for you? There's one question there. Okay, sure. Maybe I let you explain quickly what you're doing in the Ether-Risk workshop, and then are the Sülke people here as well in this room, or already downstairs? Somebody from Sülke here? Okay, we'll try to explain the other one then ourselves.
Okay, hello. Christoph Mussenbrock is my name. And I'm going to present you the 2 challenges which we have prepared from Ether-Risk. And these 2 challenges all have something to do with our first product, with flight delay. I just, can I have screen? Who has been in the session yesterday evening? So most of you know already the 2 challenges we have. Yes, we have the first challenge, which is implementing token payments. So somebody or some of you may know that tokens are a very important part of blockchain technology, especially on Ethereum. And currently, we have only a few applications, and mostly you pay with Ether, for example, for an online gambling game or for any other application. But tokens will gain momentum also as a medium of payment and medium of exchange. So we need to invent new ways how we can pay with tokens. Currently, this is still in development. And in the session today, I will show you how this could be done. It's a challenge. I won't show you the complete solution, but I will give you some hints how it could work. There are several possible options how to do this, and we will do it in a live programming. So who has been in the sessions with Sebastian Bürgel yesterday?
I think everybody.
Also
right?
everybody.
Yeah.
So you know also already Remix, the Solidity debugger and development environment. I will also work in this Remix environment so you can use your skills. And it's an experiment. We are doing live coding here, and I have prepared a document for this, and hope you all will have some fun with this.
Okay, thank you very much. The other stream about IoT is mainly how can you use sensors, Internet of Things sensors, to actually feed in data, real-time, real-life data into smart contracts on the blockchain. It's mainly about the IoT side of it. So how can you use a sensor, a temperature sensor, something like environmental sensors, like temperature, I said already, like GPS and so on, this kind of data, and how can a smart application that could run on the blockchain. So if you're interested in this side of how to work with real-time data, this would be then your choice might also be at E33.1. You can also think about whether you want to change in between, but I think it makes sense for you, for example, if they stay both sessions, or do they also understand it?
The sessions are completely independent. You can also join the second challenge. They will talk about token staking. This is a complete different mechanism. Also very interesting, has more the economic perspective also in it, medium of exchange and how to calculate price of tokens. So you can choose. You don't have to do both challenges. They are completely independent.
Okay. Good. So now we would then, everybody that would like to go to the IoT class, please go with Mark here. You're going to leave for the other room. Everybody that wants to like to work with Ether-Risk, please stay here. Der sollte unten sein dann in dem Fall.
Unfortunately, I forgot my card. Is there some
Wir,
cards where I can?
ja, wir geben dir ein eleganteres Ersatzkärtchen nachher. Kannst du in der Pause oder am Mittag schnell nochmal holen? Because we have some footage of Iterus from yesterday's session. Yes.
Ich hätte noch eine Bitte, weil es ist eigentlich keine Zeit, um hin und her zu laufen zwischen den zwei Stockwerken. Anstatt dass dann die Leute, die vortragen, gesqueezed sind, weil Leute entweder rauspassen und pünktlich beobachtet sind, könnte man nicht einfach 5 Minuten Switch-Time einbauen? Weil zum Beispiel auch wenn Ihre erste Vortrag unabhängig ist vom zweiten und ich werde jetzt zum Beispiel runtergehen, dann komme ich zu spät zum zweiten und störe hinein.
Ja.
Und die anderen können, ich weiß, euer Programm ist total eng.
Wir machen zwischen den zwei Teilen, danke, machen wir kurz Pause.
Ja, kein Problem. Ich muss auch mal verschnaufen.
Genau. Okay, we would start with the Etherisk class number 1 here. Thank you, Christoph.
Okay, let's start. I have prepared a document. Who has access to Slack? Because I posted it on Slack, so everybody should now have access to Slack to open this document. It's shared on Google Drive. Anybody who has no access to this document, please raise your hand. Okay, what's the problem? Okay. So please open the document and...
Yes, you find the Slack link also on the BIOTS.org website. If you scroll down, in the bottom area, you have a link to Slack. If you click on that link, you land directly on our Slack page. Thank you.
Okay, so first of all, please read the red disclaimer. So what we are doing here is a classroom session, so we are not going into a production code. To build production code in Solidity and on blockchain is a very special type of engineering because you have to be absolute paranoid. So you always have to assume that anything which goes wrong will go wrong, and any bug will be found and will be exploited, and you will lose money. So keep this in mind. This is not normal programming. This is programming where you directly move funds, you move values. So if you are going to build production code on a real blockchain, then you have to be aware that every bug will be found, every bug will be exploited, and you will lose money, or your customers. So be careful, and what we are doing today is not production code, it's experimental code. I have removed many security features because they would just blow up the code, and you would not understand anything because everything is clustered with some mitigations for several attack vectors, and this is very hard to explain what's really happening. So I stripped this all down, and still it's running code. It's also reasonably functional code, but it's very simplified, and just to keep in mind, don't copy this and bring this on a mainnet and hope that it will work, because probably you will lose money. So what we are doing, we are implementing token payments, and this token payment, as I mentioned, is the next version of our flight delay contract. So our flight delay contract is a fairly complicated and complex piece of code, as you can see here. These are the real flight delay contract consists of 7 independent smart contracts, which are in a contract registry with an access control feature, and we have a separated database from the business logic and all this kind of stuff. Most of the architectural decisions are borrowed from existing software engineering, so this is nothing very special. But this is complex, and so it would not be useful for such a classroom session. So I made a very simplified version of this flight delay. And a flight delay insurance contract which is stripped down to the bare minimum. And what is an insurance? An insurance is where you transfer your risk. So in the first moment you apply for a policy and you pay some money, which is called a premium. And if your insurance company agrees to this contract, then they will underwrite this contract. And this is a special function in insurance, the so-called underwriting, where the insurance company accepts the risk transfer and promises you to pay a certain payout in case of a loss or damage. So this is the bare minimum. In my example, I have simplified it still more because the underwriting process is done automatically. Our insurance in this example accepts any policy which you apply for. This is also a simplification. And the other thing is that the oracle which provides insurance with the data, if there has been a loss, is also very simplified here. So we have an oracle, and the insurance contract communicates with the oracle contract. So we have two contracts, and the oracle contract is basically very simple. It receives a query, a request from the insurance contract, and then you can look in the world and look at the flights and decide if the flight is delayed, and then you can call a transaction of this oracle, and then you will put this information on a blockchain, and this will trigger a payout. So I will try to sketch this, and you can at the same time start with the preparation. So you can open the Remix development environment, and I have put all the code on Gist, so I hope it becomes readable here. Okay, I hope you can follow. It's readable? So maybe I just sketch the basic structure. So our architecture is very simple. We have a flight delay contract, and we have an oracle, flight oracle. A flight delay sends a query, and the answer is given by a so-called callback. So the query is a function of the flight oracle contract, and the callback is a function of the flight delay contract. As you may have heard yesterday, all smart contracts in Ethereum are simply a collection of functions. And these functions are called with transactions. So you issue a transaction with your node, which connects you to the blockchain, and with these transactions you just call a function in a smart contract. So we have two entry points, or one entry point. This is new policy, and this is the only function which is to be called from the outside. New policy will then call query. Query will trigger an event in the flight oracle, and this event can be seen from the outside. Then I can see that there is an event, somebody has applied for a policy. I can look at my flight table, I can see if the flight is delayed, and if the flight is delayed, I issue a new transaction, which is called send oracle data. And send oracle data will then trigger the callback, and callback will then trigger for the customer. So two transactions are needed. The first transaction is new policy, apply for a new policy, query, then an event is raised, the event is noticed from the outside. Somebody looks at the flight table, looks at if the flight is delayed, And this information is transferred with the send oracle data to flight oracle. Flight oracle calls callback. Callback triggers the payout. This is the basic business logic behind it. Very simplified. There are no checks if the flight is valid, or there are no checks for the time and if it's in the future or not. And so this is not a real example, but the basic structure is there. And you have a customer which calls new policy. You have this oracle which looks at the outer world and which transfers the information to the blockchain. Is this clear? Any questions?
So the code thing, could you say where it comes from? Because some of us came late.
Okay.
Where did you go?
This is a document which is posted on the Slack, in the general Slack of BIOTS. And there you have one document, the first challenge. This is a Google Doc on Google Drive. And in this doc, you will find a link to this gist. Just click on the link, and then Remix will open, and you will have the code. OK, now let's look at the code. So it starts with a very well-known pattern in Solidity. It's a so-called owned pattern. Many contracts have functions which are reserved for special people, for example, for the owner of such a contract. And this general pattern is the so-called owned pattern. This can be inherited by a smart contract. This is something like object-oriented programming. So we have, for example, this owned template, and then you can inherit this by a flight delay with this is owned construct here. And so all the functions which are in the owned contract are inherited by flight delay. So flight delay is an instance of the owned contract and extends the owned contract by more functions, but all the functions in the owned contract are also functions of flight delay. So flight delay has also an owned function and an owned constructor, and has this only owner modifier. The only owner modifier checks if the contract or some function of the contract are called by the owner, and if they are not called by the owner, then the whole function will fail. And in Solidity, if a function fails, then the whole state is reverted. So everything is rolled back, and the blockchain is in the same state as if the function would not have been called at all. So this only owner is just to restrict the access to certain functions to the owner. For example, we have to announce to flight delay the address of the oracle. So we can use several oracles, and we can set the oracle address in the flight delay contract. And this is a function which obviously can only be called by the owner. It cannot be called by everybody, because otherwise you would write your own oracle, and then you could manipulate the whole process. So this is, for example, the set oracle function, which has this modifier. So only the owner may set the address of the oracle. Another modifier which we use is the only oracle modifier. Obviously, the callback which triggers the payout can also not be called by everybody, but only by the oracle which is predefined. So if the callback function is called by anybody else, then the whole transaction will fail, and everything is reverted to the state before the transaction. So these are basic Solidity patterns which we use here to restrict the access to functions. And so I have to silence my Telegram account. So now we have callback, we have the set oracle. What else do we have to explain? Yeah, new policy is the core function which is accessible by anybody. So anybody can call this function. It has no modifier, but it has some other how you say, keywords, public and payable. Public means that the function is visible to the outside, and payable means that the function can receive money. So normally a Solidity function cannot receive money. If you send money to a function which is not payable, then also the transaction will fail. This is to prevent the accidental transfer of money to a contract without wanting it. So also a security feature of Solidity. And so new policy you will see is one of the functions which have the payable attribute, and so we can transfer Ether to this contract when calling this function. There is another function which is which has the payable attributes. This is the so-called fund risk pool function, which is also with the modifier only owner. So only the owner of the insurance contract can use this function. And as the name says, it has the function that the owner can put any amount of money in this insurance contract. Why is this needed? Because if, for example, 100 people apply for a policy and we have 10 payouts, then the sum of the premiums may be lower than the sum of the payouts. So we need to provide additional capital, and this can be done by the owner by calling the function fund risk pool.
What is the underscore semicolon for?
Okay, a modifier is basically some kind of a macro. Yeah, so it becomes expanded. So you can think of a modifier as a macro which is inserted in the actual function code, and the underscore is just the rest of the function code, the function body, basically. Yeah? So if you, for example, if you have the only owner function, then this line require message.sender is equals owner. This line is inserted before the actual function body and is executed before it, and the underscore is then the rest of the function body and is executed only if this require is successful. Yeah? Require means also you perform this check if the equation holds, and if it holds, then we go on, and otherwise the whole transaction will fail, and the state is reverted to the state before the transaction. Okay, it's that's about the EVM. The EVM has several places where they can store local variables. Store local variables on the stack, or you can store it in the actual storage memory. And again, one basic principle of Solidity coding is that every line of code costs money. So for example, storing something on the storage area is more expensive than storing it on the stack. So you have to calculate, and the stack is limited. So you have to calculate where to store your variables, and sometimes it's better to store it in the stack. Sometimes it's better to store it in the storage area. So, but for these details, please go in the Solidity documentation, because it's too much for today to explain this in detail. Okay, any other questions? Fine, then we look at the actual business logic, which is here. First, maybe I explain the data structure. We have two data structures. The first data structure is an array of policy. Policy is a structure with two fields, and the first field is the address of the customer. Obviously, I have to store this, because if I want to do a payout, then I need to know where to send the money. So I need to store the address of the customer somewhere. And I, of course, need to store some details on the flight. I have simply put a string here, so you can store any string here, maybe a flight number, flight date, whatever. In the actual flight delay contract, this is a very large structure with many fields. But here in the simple example, it's only these two fields. And I have to make records on the Oracle call. So every Oracle call has to be recorded in a structure, which is a simple so-called mapping. A mapping you can imagine as a huge array, which is with basically nearly unlimited entries. And the key of this array, or is the first parameter here. It's an integer, and the second parameter is the value. So basically, we have here a very simple key-value structure, which is called a mapping. Mapping are a very powerful instrument in Solidity because the number of entries is basically unlimited. It's stored in a very compact form, but it can become very large. And for example, uint 256 is an integer with 256 bits. And basically, a mapping can store any key in such an array. Okay, so we need to keep record of these queries because the callbacks of these Oracle calls can come in any order. Yeah, so it's the flights land at some time, and as soon as the plane lands, because the Oracle is called, and so we need to keep track of all these queries and know which policy number belongs to which query. This is done in this mapping. So the key is the query ID, which is a sequential number which counts all the queries. And the value parameter is the policy ID. So for every query, I store the ID of the policy, and I can retrieve the policy as soon as I get a callback. Now the interesting function is the new policy. This is called from the outside, and it has one parameter, the flight number, or the flight string. Can be any string, but in our example, in the production example of flight delays, this will store the flight number and maybe flight date and other details. First, I check if the amount of money which is sent with the transaction is equals the necessary premium. So in our very simple insurance, all premiums are the same. They are 1 Finny. Finny is 1,000th of an Ether. So basically something like $1 or something like that. And so we all policies have the same amount, 1 Finny, and we check if the message value equals this premium. Then we increase the array by increasing the array length. This is also a pattern in Solidity. If you want to increase an array, then you simply increase the length of the array, then you have a new place to store the next policy. I get the struct. I fill the fields with message.sender is the sender address, so that's basically the address of the customer which calls this new policy. And I store the flight number, and then I call the Oracle. The Oracle call is here, the query call, and the Oracle call has a return value, and this is the query ID. So the Oracle itself has a record of all the queries, and it returns the query ID. And by the query ID, I can later identify the right policy. And I store this query ID in the queries array, and so that's all. And later on, if the Oracle calls back, then I first retrieve the parameters of the query ID and the delay. Also very simplified. We only have two values, delay or not delayed, and we have also a fixed payout, which is here in the constants are defined here. So this is a premium and the payout. So if the callback is called by the Oracle, then first I retrieve the policy ID to this query ID, and if there is a delay, I first check if I have enough money to pay the payout. Could be the insurance is bankrupt and there is not enough money left. But if there is enough money, then first of all, I retrieve the policy, and I get the customer address, and I do the transfer of the payout. So customer gets his money. Very simple, and but it's basically the fundamental insurance process. So on the other side, we have the Oracle contract. The Oracle contract has also two functions, a query function, which we already have seen, with this one parameter, which is a flight, and it returns the query ID. So what do? We first create a new query ID by increasing the length of the queries array. Then I set the address of the calling contract, because this Oracle could serve many different insurance contracts. So I need to store the contract which is calling the Oracle. This is done in this line here. Oracle caller is set to the message.sender. So this is also a very important feature. The message.sender is always the address which immediately calls this contract. So if you remember this chain, this calling chain, first of all, the customer calls new policy. So message.sender in this time is the address of the customer. Then there is a new policy function executed, and the new policy function calls query. And at this time, message.sender is not the address of the customer, but the address of flight delay contract. So the message.sender changes, and so the Oracle knows who is calling it. And so this is important to notice, that it is not the customer, but the calling contract. And then I simply trigger a so-called event. An event is simply something which can be notified from the outside. It has no function, it does not do anything. It is stored on the blockchain, so you can retrieve it afterwards, but it has no side effects. It's just like a red lamp which is blinking and which is saying, hey, somebody has called this function, and with these parameters, flight query ID and message.sender, and maybe somebody is interested in reacting on this event. And then, after triggering this event, we get the query ID and return it. So now, if I'm the flight data provider, I can now watch the blockchain, and every then and then I see such an event. And I see, somebody's asking for flight number LH123, and somebody's asking for flight number UA 509, and then I can go in my flight table, look if there is a delay, and if I see a delay, I then call send Oracle data. So we are then again here. I look at the flight table, I call this function, and by calling this function, I transfer the information from the outer world to the blockchain. And this is done also by, of course, I need the query ID, and I just say delayed or not delayed, Boolean parameter. And now I do two things. Every query can be answered only one time. So what do? I first check if in my array I have still an address which is not 0. And if the address is 0, I simply fail. Otherwise, I store the address of this in this array entry in a variable calling contract, and then I set the array entry to 0, so it cannot be called another time. And then there is a very interesting construction which I would like to explain. So basically, this oracle is a generic oracle. It can provide data for all kinds of contracts. And all these contracts only have to have one thing in common. All these contracts need one function, which is called callback. And so as long as a contract has one function, which is called callback, and which has two parameters, query ID and Boolean, then I can call this contract. And but I have, of course, to say who is. I have to define that the contract has this structure. And this is done with this simple interface contract. This interface contract is basically the bare bone of such a contract, which is calling an oracle. And it simply needs to have a function like callback. And now we see the flight delay contract from the beginning. This is an instant of such a caller contract. It's basically just an implementation of such an interface. And as long as I implement this function, callback, then I can call any contract which has such a function, and this is done by this line. I first have to say, okay, I'm now calling a contract which implements this function, callback, and then I do the actual call. This is a very flexible instrument. And so I can, from any contract, I can basically call any other contract as long as I know what functions the called contract has. And in Solidity, I can do this with this interface structure, and in any other higher order language on the Ethereum blockchain, there are similar constructions. And for example, in Solidity is so that every contract function has only a 4-byte identifier, which is basically the hash of this signature. And so I can very easily call any function in any contract without knowing the exact details of this contract, knowing the code. As long as I know the contract has a code, has a function with 2 parameters, then I can call this contract. So the Oracle can serve many different insurance contracts which have other internal models and other functions. Also, I just need to have this callback function. Okay, that's all. And now we're back to our challenge. You can now go through the steps here and simply try if you can follow all this. First, the code is already prepared, so you just have to click on the buttons in the remix. For example, go on run. And then the first step is to create the oracle. So I select the oracle here in the sidebar and simply click on create. And then you see the oracle has been created here. And the transaction which created the oracle is here. And you can see it has been successful, and the contract has been created. And now you see the contract functions here in the sidebar. And the contract has 4 functions. It has 2 simple getter functions, which are only delivering the internal state. For example, I can click on the owner function, and then I get the owner of this contract. Or I can access the array and see what's in the array. Currently, I would say there is nothing in the array, but I can call it still. But now I get an exception because the array hasn't been initialized. It has 0 entries, so I cannot access it. The next step is to create the flight delay contract. I will use a different sender address, for example the second one. I create the flight delay, and I see here in the transaction protocol that the creation has been successful, and I can now access the function of the flight delay. Also, I can click on the owner, and I will see that the owner is exactly the address which I have used here for creating the contract. And I can also check for the Oracle address, and this is the next task. So the next task would be to set the Oracle address. First I will fund the flight delay contract. So let's do this. To fund the contract, I have to send money to the contract. And sending money is done in the Remix environment by setting the value field here I set it to 1 Ether. And then I call fund risk pool, and you see it's successful. And I have now 1 Ether in this contract. Next step, We have already funded, we have checked the owner, and now we set the oracle. To set the oracle, I first need to retrieve the address of the oracle. I can do this here. Just copy the address to the clipboard, and then I go here in the set oracle functions. Important is that you need to use apostrophes here. I hope it's the right word. So, and then I call set oracle. Yeah, and you see now the oracle has been set, and I can call or I can check for the oracle address, and you see the address of light delay oracle is now stored in this variable. Next step, I will now make a transaction and I try to create a policy. So I go, choose a new account, which is now the customer account, and the customer will now try to buy a policy for LH1123. I click on new policy and I see that the transaction fails. Who has an idea why this transaction fails? Nobody? Yeah, that's need for applying for a policy. You need to pay. Yeah, you need to pay your premium. The premium is 1 penny, and I call this transaction without providing this value. So without providing money, I can apply for a policy. And now we have seen that this line has basically killed the transaction because I didn't provide the premium. This check went wrong and the transaction got reverted. Now I can do it again. I just put in 1 penny. I call new policy again. Now it works. So this is a very simple example how we can apply for a policy and now can check the results. For example, I can check for the policy. The first policy has number 0. And now I see that in the policy we have the customer address and the flight string. So the policy has been stored, and in the oracle I should now see also where it is. I did not make it public, so you cannot directly check for the queries, but I can now execute the oracle. So we are now at step L. Now we call send oracle data. Now we have seen the event. Let's see. We should see the event here in the details. Where is it? Oh, wait. Sorry, I don't know why this is not reacting. So maybe you do it yourself. And the next thing is that we call send oracle data. Now the query ID is again 0, and the result is true. Now we have to be careful because the oracle cannot be called by anybody. If I just call the oracle with the, for example, with the customer address, which is this one, the third one here, the customer address. If I call the oracle with the customer address, then this will fail, yeah, because we have the only owner modifier also in the oracle contract. So the oracle contract checks if it's called only by the owner. So I need to select the owner address, and then I can do this call. Okay, now I look at the accounts and I see the customer has now received some money. Yeah? He has received 100 Finny. He has now a bit less in his balance because he had to pay for gas costs, and so this reduced his balance. But basically you see that the customer has received his payout and everything went well. And now I can, if I try to call this again, then this will fail. Why will it fail? Because we have this line in the Oracle where we set the Oracle caller to 0 for this specific query. So there is no address in the array, and this line will fail. In the second call, this line will fail and reverts the transaction. But still, there is some danger because basically we could call the callback several times. Now this is prevented by the Oracle contract, but in the flight delay contract we have no countermeasures against calling callback many times. And so if you open the next link here, then you will see a modified version of this flight delay. And you will see that the policy structure has been extended by a so-called status field. And status fields are very important for business processes because they reflect the state of a policy. The status can have 3 values. It's an enumeration here. It can be active, it can be paid out, and it can be expired. And a policy is active as long as it has not been paid out and as long as it has not been expired. Expired means the flight was not delayed, and so the customer does not get any money. And paid out means the customer has received a payout. So we modify this policy structure by this field, and we now set the status in the different events. For example, if there is a delay, I set the status to paid out. If there's no delay, I set the status to expired, and I also raise an event so people can notice this from the outside. Now to the actual challenge. The actual challenge is to build a token payment. Basically what we have done here is paying with Ether, and now we want to pay with tokens. A token is a very simple structure. You have it here. And I just see that I'm running out of time, but just to give you an impression. A token is basically only, the most important thing is this. A token is basically a table where you map addresses to values and numbers. And the number is the amount of tokens which somebody owns. So it's just a bookkeeping, yeah? And a token is nothing else like a table with addresses mapped to numbers of tokens. And then a transfer is done by decreasing the amount of tokens from the one customer to and increasing for the same amount for the other customer. So the transfer is done by these 2 lines. And for me it's very interesting. These 2 lines is basically the fundament of a multi-billion-dollar business now. All the ICOs are working on these 2 lines, and all the exchanges are all doing nothing else than calling these 2 lines again and again and again. And if you sell tokens, then you just call these 2 lines, and you decrease your tokens and increase the tokens of somebody else where you sell your tokens. So 2 lines of code which are moving billions of dollars every day. So now we can, of course, sell tokens, but currently we cannot pay with tokens because tokens, if you, for example, this transfer function, which would be, for example, a payment, I transfer some tokens to the insurance company, and then I should get my policy. But in this transfer function, there is no possibility to call any other contract. There's no call to flight delay new policy or whatever. So this is a challenge. Implement a way how you can pay with tokens. And so you need to probably you need to modify the token, or you need to modify the flight delay. And the one simple pattern would be that the flight delay gets an approval to move the token on its own behalf. So this is also one of the standard function of a token. You can give somebody else the power to move tokens from your account, like a check. Yeah, if you write a check, you give the check to somebody else, and with the check, somebody else can move your money from your account to somewhere else. The same with a token. And so the simplest approach for paying with token would be to use this transfer from function of an REC20 token, which is working like a check. So you give the insurance a check. Here is, I give you the power to move 10 tokens from my token to your account, and then I get my policy. So this would be the simplest version. There are other versions of this payment which could be implemented by newer extensions of the token contract. So I would invite you to look at the current extensions of REC20 token standards, which are, there is a nice compilation in this link, which gives you a good overview on the different ways how we can use a token for payment. And then the real challenge is to compare the standards and to say what is the best standard which could be used for payments, and then to do the actual implementation of such a token in the flight delay in this very simple structure, and show how we could do this. So that's the challenge, and thank you very much for listening. I'm available in the Slack. You can just ask questions. I'm always also available on Telegram. We have a Telegram channel, and so happy to answer your questions.
I have two questions about payments. The first one was, you mentioned that the customer paid a certain amount for the gas, but I thought that we were supposed to pay about the gas since we set the gas limit.
Yeah.
So who pays the gas? It's only the customer.
The gas is, if you apply for a new policy, then you pay the gas. It's always the caller of the function who pays for the gas. There is currently no way to pay the gas for somebody else. So, for example, the Oracle needs to pay for the gas if it calls the send Oracle data. Yeah? So, in the real world, we have to pay the Oracle a certain amount so that it can do this transaction. Otherwise, they would lose money. Yeah? So this is currently not doable other way.
And the other question was, yesterday when you showed the front end, I saw that we could pay with tokens, but we also could pay with euro or dollars.
Yeah.
So how the program knows, and I don't know, like how he captures, like, okay, this is a token, I will put here, no, this is euro, do they put in remix?
Yeah. So this is in the simple example, we don't have payments with fiat. If you're interested, you can look at our GitHub. We have all the code of the actual flight delay public on GitHub, and there you can see how the payment with fiat is done. Basically, for fiat payments, we are using blockchain only as a ledger, not as a medium to move funds. So the funds are actually moved only on bank accounts. So if you pay in dollars and you pay basically with your credit card, the dollars go on our bank account. And if you do a payout, then we move money from our bank account to your bank account and do the payout. And the blockchain is not used for the actual payments, but it's only the ledger, and we trigger the payments on the bank accounts. So this is basically the answer. So no movement of value on the blockchain. Only if you pay with Ether, then we have actually the movement of funds between smart contracts and customers and so on. Yeah.
If you happen to find a bug, can you update the contract?
Yes, in the actual productive contract I can do. Here you can see this. All the data is in a database contract. The database contract should not be altered, but all other contracts don't have their own data, and so that we can exchange them. And in the contract registry, I just exchange the addresses of this contract, and so the next function call will go to the new contract. So we can, as long as we stay with the database contract, then we can exchange the other contracts. It's updatable, yeah. That's a very important feature for modern smart contract systems, because even our contract, they have bugs, and hopefully not bugs which lead to loss of funds, but they have bugs, or you need to modify your terms and conditions, or you need to modify your risk model. There are many occasions where you need to change the smart contract, and with such an architecture, you can exchange the parts of the smart contract system without altering the database. Any other questions?
I'm interested in this question. How does it happen actually? So you shut down your contract and then you upload a new contract?
No, I simply deploy, for example, if I have a new payout contract, then I just deploy the new payout contract, and I send a transaction to the controller that he should use a new payout contract. And then all the other contracts which communicate with this payout contract know that they now communicate with a new address. And then all the subsequent calls will go to the new address. And the old payout contract is just left on the blockchain or deleted or whatever. Yeah.
But is this feature new? Because I read that quite some places that you should be careful what you do with your contracts because they're completely immutable and you cannot update them.
Yes, the contract itself is immutable. If you deploy a contract to a certain address, then this contract is immutable.
You can replace it.
But you can deploy another contract, and you can tell other contracts that they don't call the old one, but the new one. And this is basically the update mechanism. The old contract stays on the blockchain as long as it's not deleted. There is a so-called suicide call which deletes the contract. It's still in the history of the blockchain, but it's not in the current state of the blockchain. So all old versions are kept on the blockchain, and they are immutable, and everybody can see. It's completely transparent, so I think this is still a feature of fairness, that because everybody can see if you change your system. Yeah, if Allianz changes their software systems, you never know. If we change our software system, everybody knows, and so this is basically the difference between blockchain and classical IT infrastructure.
So what if you want to change like a major thing in the architecture within the contract structure? Because you cannot change the controller one?
The difficult thing is the database contract, because if you imagine you have 1 million entries in such a database contract, then and you move to a new data structure, for example, a new field or whatever, then you need to move literally every entry of the old database contract to a new database contract. So because this is storage, this is extremely expensive. So better not do this. So we are working on an architecture where you can extend a database contract not by moving the whole database, but simply adding fields in a separate contract which is linked to the old one, and so you use the old data, but you extend it in a new contract with a new array, basically. Yeah? And so data handling of mass data in smart contracts is still an issue which is not solved really, because blockchain is basically not a MySQL database where you can simply add a column or modify the type of a field. That's not possible in blockchain. So you need to be very careful in building your architecture. It should not be altered too much.
But what if you want to add like a seventh, except for the controller registry, if you want to add a second contract?
Yeah, that's possible, of course.
How would you make the controller being able to call that?
The controller is basically a table with addresses and names of contracts, identifiers. So we have, for example, the flight delay new policy contract. And then behind this name, there is an address. And by changing the address, then it will point to another address. And so the contracts call each other by using these names, not the actual hard-coded addresses, and they always look in the registry like a DNS. Yeah? So if you say www.google.com, then you go to the name server gives you the address of Google, then you call Google. And the same idea behind this. And so this is extendable. You can also use more contracts, you can exchange this, you can exchange the business logic, you can do all kind of stuff, as long as you don't modify the database, because the database is the hard thing. Yeah? Of course, you could also change the database and you have to migrate it, and migrate is expensive.
How do they make sure that not two same names appear then it's a problem?
I don't know if you check, because the registry is controlled by the owner, so the owner should know what he does. So it's not a public accessible registry. It's only a private registry, which is only used for this purpose. So the owner should take care for this. I think we don't have any checks for this because it's not necessary. We have the full control. Okay, any more questions?
Yeah, what is the advantage over using tokens instead of just using Ether?
Yeah, imagine, for example, stable coins. You know, Ether, Bitcoin are very volatile. But now we have stable coins like Tether, like DAI, and there will be more. And I think the key for adoption of blockchain is the use of stable coins, because nobody wants to have money in his pocket where he doesn't know what it's worth next week. So stable coins are important, but the base currency of blockchains are always very volatile. So we need to have a way to pay with, for example, stable coins. And stable coins are nothing else, they're like a certain type of tokens. Okay? So, I hope you had some fun. Go in the examples, try yourself, play around, and if you form some teams, I would be very happy and happy to answer your questions. You can reach me with the online channels, Telegram on our homepage, and Slack for the BIOTS event, and so don't hesitate to ask your questions. Thank you very much. I think we do a 5-minute break, and then we continue with the second session.
Maybe we do very quick, like only 1 or 2 minutes for the people that would like to leave, because we have the coffee break in 25 minutes.
Okay.
We need to speed up a little bit.
Hi.
Scott McMyer.
Just a moment. I need to switch off my notifications here. This is very so privacy and.
It says mute background alerts for 1 day.
Where is it? Ah, thank you. Cool, thank you very much. Okay, now.
Oh, so I just wanted to talk to you real quick because I work with at Allianz with Alan Cabello.
Yeah, and I'm.
Yeah, so I am here, and if you have
Cool.
some time after.
A bit late, so.
Your mic is still on, by the way. Your mic is still on.
Okay, we continue.
So, okay, cool. Because
Let's start with the second session. Open the second document, and I think most of you have been in the first session already, so I will skip most of it, so we can just jump in the actual model. What is staking? I just want to show it. Staking is a very fundamental mechanism which you can use to incentivize certain processes on a blockchain. So the fundamental mechanism is very simple. You want that somebody does something, and but you want to enforce that this service is provided in a certain quality, in a certain time, and so on. So basically, you need some incentive which brings people to delivering their service in time and quality. This is in traditional business you call something like a service level agreement. Service level agreements are very common, and usually you have some written contract. So the written contract says if you don't deliver the service in this time or in this quality, then you will lose your reward or you will pay a penalty. For example, if a construction company promises to build a certain building in a certain time, and the owner of the building will lose his rent if the building is not completed in a certain time, then he will make a contract with the construction company, and if the construction company fails to deliver the building in due time, then the construction company needs to pay for the loss of rent for the owner. That's a very common pattern. And in a smart contract environment, we can use a similar pattern. Because in most of the transaction you get an immediate payment for a service. For example, you go you generate a CryptoKitty, then you need to pay a certain amount for it immediately. But what if you have a different service like an insurance policy, where many people need to cooperate in a coordinated way, and the success of the third in the chain is dependent on the second in the chain doing his job. So we need some mechanism to enforce or to incentivize people to deliver their services in time. And a very simple model is also, again, here in our flight delay contract, we have a query and a callback. And an insurance company promises its customers to do the payout in a certain time. And so this is a promise. And so if the insurance company would not pay out, then it would very fast lose its customer, and it would also have legal issues. So the insurance company needs to implement a mechanism which incentivizes the companies which it works together with to deliver their service in time. And this is one use case for staking. We say, if you want to work together with us, then you first need to put some money in a basket. And if you don't deliver your service, then you will lose this money in the basket. So this is the fundamental mechanism. Of course, this only works if the partner, Oracle in this case, is in some way dependent on my company. So, if, for example, if there is only one Oracle, it will say, okay, I'm the only Oracle on the world. You need to work with me and independent on my quality, because there is nobody else. And then this would not work. If there are 20 oracles, then it's a different story, because then I could say, if you don't deliver, I go to the next oracle, and maybe they are better. Or even if you don't deliver, I just go to the next oracle, which will provide the service, and I will use the staked tokens to pay the fallback partner. So this is a basic staking mechanism. And so we see this as a fundamental mechanism because in insurance you have complex business processes, maybe with many partners. Maybe you have, for example, people who do the marketing or people who calculate risk models, people who do claims management and all kind of partners. So the insurance company needs to orchestrate all these partners and the staking mechanism can be a fundamental mechanism. Another application is the staking of capital. For example, I've shown you the vision of EasyRisk. This is here. The vision of EasyRisk is are providing a platform where many people can build their own insurance businesses. And so we are building a so-called core, and anybody can build a so-called cell, and the cell is a small insurance business with own products, with own customers, and they all use the infrastructure which we provide, legal, capital, and whatever. And so it's very easy to start such a cell, and it does not cost such money. But of course, also the core is limited. The core has a certain capital, and so the amount of business which we can do in such a structure is limited. And if one of the cells is very successful, then they will need more money. And the money has to be provided to the core because the core is the responsible to show this capital to, for example, the regulators. And so we need a mechanism that people which are in the cells can provide capital to the core. And this is also a staking mechanism because this capital is then locked in the core. And it can only be retrieved if the cell stops its business. Then it gets the money back. It's like basically like a cooperative. If you know this in Switzerland, in Germany, you have cooperatives. You put some money in a cooperative, then you can, for example, live in a residential compound of this cooperative, or you can use in an agricultural cooperative, you can use the common infrastructure of this cooperative. And if you leave the cooperative, then you get your money back. Same here. But as long as you are operating your business, the money is locked here in the core. And these are relevant amounts of money, so this is also a very interesting use case for us. So let's see how we can implement this. Basically, we need a mechanism how we can lock tokens. I won't go, because of the time, I won't go too much in the details in Remix. Basically, you need a contract which is able to lock tokens. And I will see if I have it here that I can show it again. So this is the basic mechanism here. We have a so-called token stake contract, and this token stake contract is nothing else like a contract which is able to receive tokens, to keep tokens, and to lock tokens for a certain until a certain event happens. And this is a very flexible structure. There are basically 4 use cases or 4 functions. So let's see if I can. Okay, let's see. So the token stake contract is a smart contract. And it has 4 functions. The first function is stake. So somebody can put tokens in this contract. The other function is stake 4. So you can also do this for somebody else. For example, I put tokens for you in this contract. So I can put my own tokens in the contract, and I can put my own tokens for somebody else. And then again, I can release the tokens, my own tokens, and I can release for somebody else. So for example, if I I want to give somebody tokens for some reason, but not now. I can put them in a token stake contract, and I can define a certain condition under which these tokens are released for somebody else. I can do this for myself, and so for example, a vesting contract would be an application for such a stake 4. For example, you have a company which does an ICO, and it's very common that some people, advisors, get some tokens, but not now, but maybe 1 year later. And then the company will put some tokens in a token stake contract, which has, for example, a time clock attached to it. And this time clock will then count the time, and at some moment in the future, it will release the tokens for these advisors or supporters or whoever founders. And so the token stake contract can be used as a vesting contract for an ICO, for example. But also it can be used, for example, in the flight delay context. You can say the Oracle stakes tokens in a token stake contract, and the release cannot be done by them, but only by the people who can decide if the service level agreement has been met. So the release function will be called as soon as the Oracle has delivered its service. And so the task for you would be to implement, with this general pattern of a token stake contract, to implement such a service level agreement. So the token stake itself is only the generic pattern. You need to attach some condition. For example, in this here we have the clock. Yeah, the clock triggers this release functions. The other method would be to attach some kind of a KPI, for example, for measuring the SLAs. We would measure some KPI, and if the KPI is met, then it triggers the release of the tokens. So the task in our challenge number 2 is implement such a mechanism for the Oracle. The Oracle, in the simple example, shall get its tokens if it delivers the callback a certain number of blocks after it has been called. So this is a very simple model, simple example of such a task. I have it here in the document. So the KPI basically is here: deliver the callback within, for example, 5 blocks. And so here, task number 5 and 6. Modify the flight delay symbol. So the flight Oracle has to stake 50 tokens of a sample token, which is also in the example. So task extends the flight delay contract in the example that the Oracle has to stake 50 tokens so that it can be called, and that it will use 50 tokens for each query where the delivery of the callback is not within 5 blocks. So a very simple KPI. And of course, such a condition can be more complicated. It can also be the other way around. You can use it for rewarding. For example, if there is only one Oracle, then we have seen the staking won't work because the Oracle has no incentive to stake tokens because it's the only Oracle on the world. And then you need other mechanism, for example, rewarding. You can say for each query which you answer just in time, then you get additional tokens, and so you have an incentive to do this. So the staking is not only for using as penalty, but also as a reward mechanism. And now the second part of the challenge is to discuss the economics side of things, because maybe you have read the discussion in the Ethereum world, which is how can you evaluate a token? There are many ICOs and many tokens in the world, and currently there is much speculation, and you see tokens which basically have no real value, only 4 pages of white paper and a valuation of billions of dollars, like the famous Tron token, which is still, I think, in the coin market cap on position 15 or so. It has basically no substance, but people value it very high. And many people have started to think about how to evaluate a token. And there is one famous model for this. This is the so-called Boniske model. And it's based on a certain formula, the so-called medium of exchange formula. And it's the first approach how we can give a token a certain reasonable valuation, a fundamental valuation. That's what we would like to give you as a task. Read this model, try to understand it. It's very good explained there, so I'm refraining from doing it myself because it's a difficult topic, and Boniske has done it very well with graphics, all the stuff, and also the time would be a bit short today. So the basic idea is the value of a token has 2 parameters. The first parameter is the transaction volume. So the higher the transaction volume, the higher the value of a token. That is, I think, not difficult to understand. A token which is not used has no value. And a token which is very frequently used has a high value. The other component is that a token which is not held by anybody is also of no value. Because imagine a token which has a high transaction volume, but nobody holds these tokens. It's just used in the moment where I do the transaction, and then, for example, I need to buy a policy with this token. I go to an exchange, I buy the token, I buy my policy, and then the insurance sells the token right away. And so basically you only need 1 token, and you can the whole transaction volume can be done with 1 token. And so the token is circulating very frequently, and the so-called token velocity is very high, and a high token velocity leads to a low token value. And this is the second component. So high transaction volume, and on the other side, you need to incentivize people to hold tokens, because holding tokens reduces the velocity. Reducing the velocity increases the demand, because there are less tokens in circulation. And it's also intuitively very easy to understand that the less tokens are in circulation, the higher the value of the token. So we need both. We need higher transaction volume, and we need an incentive for people to hold. In our Etherus token, which we will do also, our ICO, maybe in I think 2 months, we start our ICO. We have exactly these 2 components. We have, first of all, a need for people to do transactions. You see again our graphic here with the cells. People need these tokens to become member of this structure. So there is a transaction volume because people need to buy it. On the other side, the tokens are locked in the structure, so we have an incentive and a need for people to hold it. So we have both components, and our vision is that this keeps the token value high. And the task for you is now to build maybe a simple Excel sheet where you can examine this hypothesis. Yeah? The hypothesis is that the token value will rise. And the task is build a simple Excel sheet, for example, based on the Boniske model, and prove or disprove that our hypothesis holds, that we will create raising token value with this token stake model. And to give you some parameters, we have a sample token in this example, in this economic sample. And the parameters are, we have 1 million tokens. The token price currently is maybe $1 to make it easy to calculate. And now we have projects which need to buy these tokens to be part of our structure. And for every project, you need 100K tokens. And every year we have 5 new projects which go on the platform. So these are the basic assumptions. You can take them for granted. And additionally, all the insurance which are bought on the platform have also be paid in these tokens. And this creates also transaction volume. So with these assumptions, you should do a simple calculation and try to figure out what the price will be in 5 years. And so this is the challenge. Build a simple Excel-based economic model which calculates the price of the tokens in 5 years under these assumptions. That's all what has to be done. And tasks 5 and 6 are the simple implementation of such a model in our flight delay example. Again, I hope you have fun doing this, and I think both parts of the challenge are independent, doable. So if you don't like programming but you like Excel, then do the first part. If you are more in programming, then skip the first part and just do the implementation. Both are welcome. I hope you have some fun in the next days. And if there are any questions, just ping me on Slack and I will try to answer. Thank you very much.
Thank you very much, Christoph. So yeah, please, for questions, use Slack. We're now going to have a very quick coffee break. So I would like you to move down to the coffee area, very quickly grab something and come back up here as soon as possible, because we're going to continue in 15 minutes at 10:40 here in this room. Thank you.
Just in time.
Ich bin gerade am Jury zusammenstellen für die Challenges.
Was ich machen kann, könnte nochmal die beiden Challenges, die ich jetzt vorbereitet habe, nochmal mit einem Art Muster, ja, also wie wir da was erwarten.
Ja, ich würde eigentlich die Ergebnisse nicht. Ja, wenn du was für die Jury hast, einfach nicht mit allen teilen. Du kannst uns natürlich. Und dann werden wir die an euren Challenges arbeiten, können wir dann ein bisschen anhand von dem abbewerten. Ja, das wäre das auch. Ja, wenn du das vielleicht mir mailen kannst oder Private Channel auf Slack, Stefan und Klaus.
Gut, mache ich. Und ja. War gespannt, was da rauskommt.
Wir haben eigentlich noch ein kleine Speaker geschenkt, aber das werden wir in dem Fall zuschicken.
Ja, ich bin öfters mal hier.
Okay.
Hey, grüß dich. Gut gemacht. Hi. Hallo.
Stefan.
Ja, sein. Du bist der Veranstalter.
Genau, und du bist
Ich bin von Aon, einem Versicherungsmakler eigentlich.
cool, super.
Ich bin hier Advisor sozusagen bei ASOS.
Wirst du noch hier sein oder musst du auch?
Wir müssen jetzt weg. Wir müssen einen richtigen Termin
Nee, ich habe nur gedacht, also natürlich wäre es ideal, wenn morgen ist so dann der Hackup, also wenn die heute Abend ist eigentlich die Group Formation und dann werden die Leute wahrscheinlich noch Fragen haben, aber wenn ihr euch auf dem Slack-Channel vielleicht ab und zu da auch schauen könntet, ob da spezifische Fragen werden. Ja.
Hilfst du mir mal? Ich bin kein großer Techie. Ich habe zwar Slack, aber du kannst mich da gerne irgendwie zuschalten.
maybe
dupliziert
we
ist.
exchange them on
Es
the
ist kein
side
Netz,
in
ne? Ihr
our
habt kein
tokens,
ordentliches WLAN hier oder so.
but these
Es
are
gibt
different
eines,
options. Yeah.
aber Moment schnell.
Aber das klemmt.
It's open to you how you
Das
want to
Public.
do it.
Hast du Eduroam? Nein, wahrscheinlich
Habe
nicht.
ich schon, aber das geht ganz schlecht. Also ich habe es wieder ausgemacht.
Okay, ist das wahrscheinlich ein bisschen überladen. Darf ich kurz?
Aber gern. Darf ich so ein Wasser trinken bei dir?
Ja, klar, kannst du nicht nehmen.
Yeah. Yeah. We are examining all
Wo
types
ist denn der Browser?
Meiner ist.
options. So we are not
Schon zu
limited
Nee,
to one.
4 Wörter.
And I'm very sure
Das
these
hat
things
viele.
will evolve.
Ziemlich
and,
viele Apps.
I think in 1 year we are much we have much more insight, and so currently we just try to keep all these options open. And, we still don't really understand how a token value is and what the relevant parameters. And we have now this Conisco model, which is a start, but it still has many.
Wie weit ist es hier nach Zürich enge?
Ist tatsächlich ein bisschen schlecht hier, das Internet. Müssen wir hier mal kurz raus.
Dann
gibt's noch
will ich auf
Apps.
E zurück. Dann musst du
Okay,
ans Fenster gehen.
Wenn du auf die Website gehst von BIOTS, auf BIOTS.org, da gibt es unten einen Slack-Link.
Second choice,
Also ich habe Slack, aber du musst mir sagen, wo. Also
Eben, du kannst entweder hier suchen, BIOTS, aber ich weiß nicht, ob du den gleich findest. Wahrscheinlich so das
and Oraclize is
geht nicht.
a classical intermediary.
Sonst hat André deine E-Mail-Adresse, denke ich, oder nicht?
But
Nö,
I
habt ihr nicht.
don't see them.
Hast du ein Kärtchen?
Nee,
Don't know how
kann ich schon
it works.
aufschreiben.
Maybe prediction margin
Mal auf,
can
dann
be,
schicke ich dir den Link, wo du dann direkt reinkommst und dann
Ja.
bist du dann auch via App gleich drin.
Okay.
And,
Schreib mal T.Noack, N-O-A-C-K,
connections to other projects.
N-O-A-C-K.
How prediction margin play a role in
me.com.
insurance context.
me.com. So.
Currently, we don't have the time to follow all these questions, so we need more people like you.
So big. It's every week there's a lot of stuff new. So hard to catch up.
Okay, schicke ich dir
Okay.
gleich.
Danke dir, nett.
Dann?
Wir hauen ab, ne?
Ja.
Wir müssen irgendwie, was nehmen wir, ein Taxi? Wie weit ist denn das bis Zürich enge? Kann man da Straßenbahn fahren, oder?
Ja, da nehmt ihr idealerweise ein 6er-Tram. Das fährt eigentlich gleich
Oder
hier bei
Unidos.
ETH. Ja. Und das fährt direkt bis Zürich Bahnhof Enge. Kurz nachschauen, wie lange das dauert.
Dann nehmen wir doch ein Taxi.
Das könnte eigentlich fast so schnell sein mit Taxi.
Wir müssen nach.
Also mit dem Tram geht 17 Minuten.
43. Okay, das passt.
Gotthardstraße 43. Naja, das ist, ihr habt in 5 Minuten ein Tram, das losfährt, das
super.
sollt ihr gerade schaffen, dann seid ihr 10:47 Uhr Tunnelstraße und dann in 3 Minuten zu Fuß.
Und sag, Tickets gibt es in der Tram.
Nee, an der Haltestelle,
Okay,
dann müsst
dann
ihr
müssen wir jetzt
müsst ihr ein
los.
bisschen schneller machen noch. Ja. Danke dir. Tschüss. Pass gut.
Geht. Ich muss mir noch einmal kurz ein IPFS-Ding aus den Fingern lutschen, weil einige danach gefragt haben. Hey, sorry. All a little bit last minute.
Guten Morgen. Alles klar?
Hey, ciao.
Servus.
Jawohl.
Gut.
Alles runter. Wir haben
Brauchst du
gestern
noch ein
hier...
Wasser mit oder ohne?
Geht, danke dir. Ja, ohne ist vielleicht gut. Genau.
Ja, ich kann nicht kommen. Ich muss
Ja, easy.
meine kleine Family besuchen. Ich
nur-
bin die ganze Woche hier.
Ist auch irgendwas dran?
Nee, ich hab
Okay, welcome back, everybody. There has been a few questions on Slack, so we're really sorry about the limited space at the IoT session before. We're going to make the slides available through our SCED program, which you can find on the official biots.org/program website. There have also been a few questions about the challenges. So the challenges that you have been presented now by EtherRisk and all the others, you can work on them. They're going to be in the open challenge category. The official challenges from our partner institutions like EWSAD, UBS, Future ICT2, they're going to be all presented this afternoon in our challenge introduction session. You can afterwards then during the group formation stage decide who you want to work with and what challenge are you going to work on. We're also creating a separate channel for every challenge on Slack afterwards where you can discuss and where you find more information about these challenges. Right now, I don't have to introduce you again. You know this guy already. Sebastian is going to give you another introduction into Ethereum coding until lunch. Thank you.
Thank you, Stefan. So I would like to take you today, after yesterday we walked through the basics of smart contract development, to the next level, because it's nice that we have a smart contract. It's nice that we have kind of a self-enforcing and kind of trustworthy, I don't want to say financial infrastructure, but like some infrastructure that you can leverage to build decentralized applications if they have a financial character or not. Like, it's important that blockchain is not just about finance, right? Finance is maybe not the most appealing topic to many of you, but we've seen like issues with insurance space. We've seen yesterday how other startups in the space are leveraging blockchain for data management, such as Ambrosus and Modem. And this, in my mind, are good examples of how blockchain can help us with non-financial applications. Now, the thing is, we need to interface that somehow, right? So we need to interface our smart contract in one way or another to the outside world that do not work through a command line terminal on a, for example, a Geth node, like a Go Ethereum node. And today what I'm going to show you is how we do that. And admittedly, this blockchain technology is not really ready for, competing with Twitter and competing with Facebook and competing with Amazon. I do see some startups that try to kind of tackle that today. I think that's a quite ambitious goal just because none of the core infrastructure is there, right? None of the, how do you build Facebook when you don't even have a browser, right? So what we have with this blockchain is barely a dial-up modem, right? So this requires some kind of hacky tools, and I want to show some of them today. So just as Solidity is very much JavaScript based, the other tools that we have are also very much focused on this JavaScript ecosystem. So there's a library called Web3.js. So Web3 is kind of the idea is that we had the Web 1, then we had Facebook and Twitter and all this Web 2 stuff, and Web 3 is about the decentralized internet, right? So in actual internet that is actually decentralized and basically goes beyond the current consolidation that we see in the web space. Now, what I want to build with you and show you how we interface stuff is like this very much Web 1.0 looking website that is actually interfacing stuff on a blockchain, even if it doesn't seem like it. Anybody has a clue what this very funny looking GIF there is? I didn't do that myself. Where you found that? This is actually a piece of art that was produced by a major Swiss financial institution on their first web presence of online banking in the year 1994. And it's Credit Suisse, right? So if you think that's how online banking looked like, that's how it was in the 90s. And we're going to build something like this that might not look pretty, but that's okay. It's a hackathon style environment that we're working in here. And we're trying to get the features there. So what we have is basically the ability to read data from the blockchain and to write data into the blockchain. And from that, you can basically build whatever you want to. So the first thing that we're going to need is some sort of gateway, how your website or a web interface specifically could interface that. And how we do that is with a Chrome plugin. So it would be useful if you have Chrome. There's also a Firefox version, but I've never tried it myself. And if you install this MetaMask extension, I pasted it into the general channel. So you see this MetaMask Chrome extension. It's okay, again, there's many people in the room, so internet is not fully there. So basically, you can also just go to Chrome extensions and scroll on the bottom and click on Get More Extensions. And once you're online, you just search for MetaMask. And you'll see this very friendly-looking fox. And now one thing that I do want to mention is, just like with the early internet, where people wanted to, lure you onto some funny-looking websites to enter all your passwords and get access to your online banking, the exact same thing is happening in blockchain space, right? So you will see you will see scam versions of MetaMask. You will see scam versions of pretty much any tool that is around. And like literally hundreds of thousands of dollars have been stolen just because people were falling for that. So please do make sure when you install something, is that the right tool, right? Please, I don't need to explain to you how that works, right? You do understand that if something, I don't know, has like 2 installs and looks a little bit dodgy, like beware of what might be going on. So even like Google spam filters are just not working for this sort of scams that are ongoing right now. There's a lot of money that's at stake, so please beware. So we can install, so I installed this Fox already. So you install the MetaMask extension and then have this friendly looking Fox up here. And first you have to unlock it. So let me start from scratch. So I will basically log out. You will see this Fox here. One of the most important features is the animation. So and after you log in, you probably end up in a view like this. Probably you don't have any money. I have like 8 cents on here. So in this wallet, I have 8 cents. Also, maybe don't store a lot of money in your browser because your browser is not exactly the most secure way of storing money, right? So if you store significant amounts of money, I would suggest that you have a hardware wallet. And one hardware wallet made in Switzerland is this digital bitbox here. That you can use to more securely save money or or store any assets on your machine, which will actually have a private key that only resolves the thing. So for now, we're just going to play around. So this MetaMask is kind of convenient. So if you have it, you can choose the different networks up here. Now, what these different networks are, you have the main Ethereum network. So it's real money on there. So this is real 8 cents that I have on here. And apart from that, we have these test networks. It's kind of different flavors of the Ethereum network, but I would suggest you work on the Robston test network. And I have like almost $2,000 on here. It's not real dollar, okay? So what you can do is, if you're in Robston, you can click on this buy button, and you will be forwarded to this Robston faucet. You can just request some test Ether here. So you see this account here has a ton of money, and you can just click here, and you will see a transaction. So what you can do here is we can check it out on Etherscan, just like yesterday, what's going on. So currently, you can also click multiple times. By the way, if you click more than 10 times, it tells you that you're greedy. So now we are basically waiting for money to come in. We're waiting for money to be transferred from this faucet to my MetaMask address. And this will take, depending on, as we discussed yesterday, depending on the gas price and the backlog of pending transactions, however long until some miner is kind of generous enough to accept my transaction. And eventually you'll see that here in your MetaMask transaction list. All right. So let's see, the gas price here is 1 gigawatt. That's not as much. It's not in our control because we're just asking some web service, this faucet specifically, please send us some money. And now it got mined, right? So my balance increased to 3 Ether. All right, so now that you have some test Ether, you can use this account to make a transaction. And just when you are setting it up, it asks you to store this mnemonic. So it's like a seed phrase that is used to recover your private key. It's just a bit more of a convenient way to store a private key, because if you have it hex encrypted, chances are that you have like a typo somewhere and you can't access your funds anymore. So if you have like these words, it's a bit less likely that you mistype it and lose access to your private key and all your funds. Okay, so what this thing does, it sounds scary, but it's actually, I think it's okay. So it injects a little JavaScript object into every website that you load. And it's a Web3 object. And this Web3 object allows you to interface smart contracts and to make certain functions that basically they provide for us. So for example, you can go on this website. You can go onto View, Developer, and Console. So you have this. So you have this Web3 console, this Web3 object here, and this is the thing that got injected by this Fox up here. So, for example, you have functions like web3.eth. Get accounts, and the thing is here that these functions here are asynchronous functions. So if you want to hack with it in the command line, you need to provide like a callback function. So I just put a little callback function in here. It's kind of this usual error response scheme that it takes two parameters. The first one indicates if there has been an error, and the second one is the response that you get. Just that you have seen it in line here. So I just dump the stuff onto a console, what I get back here. And this allows me then, for example, to do things like this, web3.eth. Accounts. Oops, accounts is not a function, so I just see what is my current account, and then I can do things like web3.eth get balance. And I want to get the balance of my first account. So this is the current account which I have selected and unlocked in my MetaMask. And I'll pass it as a second parameter. I'll pass it the callback. Yeah.
Could you put the console on the side of the screen?
Oh, sure. Yeah. How does that work?
It's on the right.
On Oh yeah. Yeah, better?
Maybe to the right.
Okay. Any specific wishes here? Good. This better? All right. Why is this on the other side? Okay. All right. So, yeah, what is this? This looks really weird. Now, what I did here is two lines that matter. Is this one here, I inlined a function that is basically a callback function that takes an error. The first argument is an error, the second one is a response. And I console log it, so I just dump it on the console, the error object, and then the response. So then I call this web3 ETH get balance. So this is just a typical style because a blockchain is a database. And as some of you might know, you should not query a database in a synchronous call because you don't know how long this other entity takes. That's why we do an asynchronous call, which means I'm standing here and I'm telling you, hey, please give me this. And then I don't know how long it takes you to give me this. So I provide you a function which is being triggered upon your response, right? And I can do whatever. That's basically what these asynchronous calls mean. Now, what I did then here is I said, hey, web3 ETH, please give me the balance of the following account. Once you do have it, pass it into this CB function, which is just a callback function up here. Then we see an output. The first one is undefined. That's the error object, so there were no errors. That's good. And the second one is this weird object. Now, this weird object, I actually expected a number. And the problem with numbers in Ethereum is that we have this word size of 32 bytes. So the numbers are really, really large. And JavaScript and many other languages, like with their native objects, can handle such large objects. So this is actually a big number object. It's another JavaScript library. And you can use that for doing maths on it, because if you were to operate on really, really large numbers in JavaScript, you'd get weird results. Like it basically can't add really, really large numbers. So what we're simply going to do here is in our callback function, I'll change our callback function a little bit. In that I write R, so that's the result. I write to number. And call my get balance again. So this exported it to a number. Just beware that if you do calculations on it, sometimes weird stuff might happen, that you add a 1 and it doesn't actually show it. That's because it can't display it. Yes, so this is fundamentally how we can operate with the Web3 library. You can query data from the blockchain. Currently, for example, I queried my balance. Now, how does it work behind the scenes? What's going on here? How does this thing know what a blockchain is and how to query data? So what is happening here is that by having the Fox, by being connected to some of these endpoints here, this is basically there is an Ethereum node that is running the Robston testnet, and this one is being synchronized, and you access it, right? So you're basically trusting their server to give you the right data. And you might already hear that this is not exactly what blockchain was designed for. Blockchain was designed such that you trust your data. There is no party that you really need to rely on to give you the right data, right? So this is really a very fundamental thing. So the overall design philosophy is that there is no kind of trusted server or stuff like that. And now we have this Fox in here, and we have to trust their server. You might say, hey, that's maybe not a very good idea. What you can do is that you can, for example, run a local Geth node, so you can set up your own nodes, you sync the blockchain. If you do it in fast mode, it takes about 12 hours. If you do like the full synchronization, so including all past state transition verifications, it takes about like 2 or 3 days. You can then connect this MetaMask to, for example, localhost port 8545. That's the default port where this remote procedure calls are being made available. So this is one way how you can set up your interface, your blockchain interface, in a way where you don't trust other parties that much. Why do I say have to trust other parties that much? Well, because you still just installed an extension of Chrome into your browser. You can basically also look at that because all of that is open source anyway. All right, so with this we have basically we've basically tackled how we can interface the blockchain here. Now let's look at the next more interesting example of how can we actually interface smart contracts. How can we read and write specifically? And for that we will also use MetaMask. So we'll use MetaMask for reading and writing. But we will not do that in a command line. We'll just set up a little project in which we can build that. Any questions until here? Okay, let's go ahead. So this thing which I was sharing with you here, I was sharing the GitHub link in Slack. So this is a public repository. And it's Validity Labs /ETHDAB boilerplate. So, and this thing, you will now need Git. If you don't have Git installed, you can download this thing here. So you can download a zip file and then open it on your machine. So maybe the little bit cleaner way I will show here now. I have Git already installed. If you don't have Git installed, there's various clients. There's either command line clients or user, like with a shiny user interface. So I'm going to use the command line. I'm going to make it a little bit bigger for you. So let's make a BIOTS folder. Oh, that's bad. Okay, good. And now what we're going to do in this one here is we are going to git clone this repository. So now I have a local copy of everything that's in there. So a tool that I generally recommend working with for any sort of like blockchain development is Visual Studio Code. So Visual Studio is like this very fancy development environment by Microsoft. And Microsoft has to get a bit more fashionable, they realized, so they do open source stuff, and they came up with this free version called Visual Studio Code. And it's actually quite, it gets quite some love in the decentralized space and so on. So we have this tool, you can install it. It makes things a bit more convenient, but of course you can use any IDE that you feel comfortable with. Also here, I was pasting the link in the BIOTS Slack. So you can just download it and install it for free from code.visualstudiocode.com. Wow, it's not really fast today. All right, so if you have that, you will basically have an IDE that looks pretty much like that. And the reason why I recommend this one specifically is because you have extensions. And these extensions, for example, provide syntax highlighting for Solidity, and also has like an integrated compiler, and you can just press F5 and see if there's any errors, compile errors in your Solidity code. So in here on the left side, you can install extensions. You see I have a few extensions. The one that I would like you to install then is this Solidity extension. So you can simply type up here, Solidity, and the one by Juan Blanco is the one that we want. It's like 65,000 installed, so that's the one you want. Okay. And what I'm going to do now is I will open this repository which I've just been cloning. So this is the repository that I was just cloning. And what we have in here is obviously our funny animated GIF. We have a custom JavaScript file, which is doing some of the magic that we will get into. And we will have a very simple HTML. So in this HTML, I'm just loading some jQuery. It's not exactly the latest version, but it's a tool that might make things easier for you if you want to work with user interface. It's kind of very, very easy and to quickly go for some UI. And the next thing that I'm doing here that is relevant, so I have some text boxes here. I have a form, and then I have like a container. And this container with this ID content, that's what I'm using to write the data that I'm reading out of the blockchain. And then we have this submit form here, and the submit form has an input text field that is called greeting, and this greeting is going to be written then into the blockchain. Yeah, so one div into which I'm writing, and one input field from which I'm reading for writing it into the blockchain. And finally, we have we are just including this custom JS file, which is the JavaScript file that does part of the magic. Now, and the magic is actually not that big. What we have in our, actually, let's first look at the smart contract. It's a very simple Hello World smart contract that we touched upon yesterday. So if you open this SOL file, you see there's syntax highlighting, and this is, if you don't see that, it's because you don't have the Solidity extension installed, right? So there's a Solidity extension installed with syntax highlighting, and it starts complaining already that currently I'm requiring a version that is older or that is newer than what Visual Studio shipped with or the Visual Studio extension shipped with. This is generally a bit of a problem that there's a lot of development in Solidity still, so the language features are still evolving really, really quickly. And there's quite sometimes even breaking changes. So some of these plugins and some of these toolings don't have the latest version in here. So I'm going to downgrade that one to 0.4.17. I'm not using any kind of novel features in here anyway. So what I'm doing here is I have the more naive first implementation where we have an explicitly implemented setter and a getter. We've seen yesterday that I could simply make this greeting variable public, and the getter would be generated for me automatically. All right, so this thing you can compile via, for me on Mac, Command F5 or FNF5. And so compilation was successful, and I have two warnings because I was not nice and I didn't specify that these things should be public. That was, I think I wrote this thing before the latest parity exploit. That's when we didn't have this default in. Okay, so this basically worked. Now, after I compiled it, you see that Visual Studio Code provided you a bin file. And what you have in this bin file is basically three things. So you have an ABI file. ABI stands for Application Binary Interface. It's pretty much a JSON version of a C++ header file. So it contains the header definitions of all functions that you have in your smart contract. And if we look into it, okay, that looks a little bit ugly. Let's JSON lint that. Can people stop downloading? Yes. So basically what we have in here is we have a section for every function. In my case, it's pretty boring because it's just two functions. So I have the function called setGreeting, and I have a function called getGreeting. One of them is not a constant function, meaning this is a function that writes to the blockchain. You will have to pay gas for it, and it will be broadcasted to the entire network. The second one is a constant function, meaning you only read from it and it doesn't get broadcasted to the entire network. You see some input parameter that it gets and output that it produces for you. Good. Okay. And the second piece of information that we have in here is this bin file. So this bin file is basically just the compiled binary version of your source code. This is compiled. If you ever want to work with that, like from here, make sure that, or beware that it's hex, but it doesn't have the 0x prefix. Yeah, so this is a common gotcha. And finally, we have a JSON file which contains both of them. You have the ABI, you have the bytecode, and some other stuff that might be useful. And then the next thing that we do is we basically just have to tell our Web3 object. So Web3.js is this library that provides functionality for us to interface the smart contract. And if you want to interface a smart contract, you can basically get a JavaScript object and you're calling functions on it. And this is actually really cool because you're calling functions on a JavaScript object that are actually being executed on the blockchain. So I find that pretty cool. And these functions are totally abstracted, like you don't really feel that this is doing stuff on the blockchain, and the transactions and the signing happens under the hood through MetaMask for us. Okay. So now let's have a look at how this actually works. So we have the setup of the Web3 object in our custom.js file. So in our custom.js file, we have the contract address and the ABI. So we need to know, of course, if we have an instance of this smart contract somewhere, we just need to know which address is it. Like, where is this thing written? And that's why we need the address. The second thing that we need is this ABI. It's a JSON, which is convenient if you work in JavaScript. So the next thing, and this is really, I just provided the boilerplate for you. You can pretty much use exactly the same thing if you're going to build with it. And then integrate it in whatever form you need it for your web front end. So we're just checking, hey, if this Web3 is undefined, or it's basically complaining that it doesn't have Web3. So you can basically take a look at how this looks like when you deactivate the Fox. So you go to extensions. Where's my MetaMask? And if I disable it, then of course you can't access it. And what you see in the console here is, it's complaining that it doesn't have Web3. Now, this is basically just a sanity check to make sure that this thing is there and that you can handle it correctly. So I enable this one again. And of course, what is also required, if you want to make writes to it, you have to unlock it. So this one is currently locked. Yeah, and now it's complaining, it gets some weird error message. This is either because your account is locked, so MetaMask can't do anything, or because you're connected to the wrong network. So now I provided an address for our smart contract, and this address is living on and I wrote it in the source code. So this one is on the RingB testnet, right? So we have to make sure that this contract is living at the right address. Yeah, because otherwise in this other blockchain, it's really like parallel universes that have no connection at all. You have the mainnet, you have the RingB testnet, you have the Robson testnet. They have nothing to do with one another. But interestingly, if you have one address, this address is, unlock it, this address is the same across networks. So I have a mainnet address, which is 0x639. I have a Robson address, which is exactly the same. So you have the same address across different networks. Because what an address actually is just a reformatted version of the private key that's behind it. And the protocol is the same, right? The protocol that runs behind the scenes is the same thing. So that actually raises a pretty interesting question. If you send me money on Robson, right? You see where I'm going? Can you use it on the other net? It would be pretty bad, right? You send me 10 Robson Ether, and then I just take myself like 10 mainnet Ether by taking the exact same transaction and broadcasting it on the other net. So there's a network ID, which is part of the message that gets signed by your private key, and this message is not matching the mainnet ID. This is, however, and this is also a very interesting side note, this is a serious issue if there are forks in a network. So if there's two parallel versions of the blockchain because of some dispute in the community typically. Because then, and we've seen that in Ethereum specifically, you have two versions, like until some point there's a block, there's a block, there's a block. And from some point forward, we have two parallel versions of it with the same network ID. So then you really have to make sure that nobody is replaying transactions that are valid on both sides of the chain. Okay, but basically this is being taken care of by a network ID, and don't be worried, like you can use your address on mainnet and Ropsten network. Just people might know that it's you if they know they interacted with you in the Ropsten net. All right, so what we're going to do now is we will need to bring our smart contract now onto the Ropsten testnet and make this work here. So let's do this. So what I'm going to do is I will take our smart contract and we will deploy it on the on the Ropsten testnet. So I'll copy paste this smart contract and we'll go back to Remix. I have to reboot Remix. Sometimes Remix needs like a Control-Alt-Delete. So what we can actually do with Remix, which I like a lot, is that you can use it really to deploy and interface a smart contract. And what I would like to test with you is, let's some other tests. Let's make a BIOTS.sol. So what I'm going to do now that you have MetaMask installed, if you click on Run, you have this additional option which is default selected, which is called Injected Web3. So this means whenever you click on Create, it's going to attempt deploying your smart contract through the network that you have selected here and through the account that you have selected here. By the way, you have an arbitrary number of accounts that you can create here, and you can send yourself money. So basically what you can do is you can go to account 1, and I'm going to send almost $1,000 to no, that was wrong, the other way around. I'm going to send 1 Ether. By default, it's not way here, it's Ether, beware. I'm going to send it to account 2. So $800. Now, I don't want to wait too long. I'm going to go for a ridiculous gas price of 100 gigaway, and I would pay $1.7 to broadcast it. It's just because I don't want to wait, right? I just put it 100-fold higher than what it could be. Submit it. Now it's going to take a bit until it reaches the other one. Okay, so you can use these accounts here and use that for broadcasting. Now, it's being funny. Let's reboot again. So I'm selecting some compiler version. And from here we can then basically, when we click on this create button, it's going to broadcast this transaction through MetaMask onto the blockchain. Okay, this worked. I know why I had to select an older compiler version. All right, so now I selected 0x639. By the way, sometimes it's also being a bit funny when you change your account but stay in MetaMask without reloading the page. There's sometimes some quirks. Okay, so just stay in one account and you're going to be on the safe side. So what I'm going to do is I create an account now, and I create the smart contract now. I have this pop-up of MetaMask, and you see already this one is actually a lot more pricey than this pure Ether transfer. The pure Ether transfer was 21,000 gas. This one here did a gas estimation, so it knows how much it's going to cost because it just knows the code, it knows the constructor functions, so it does a gas estimation and puts it in here. You can choose, you can of course increase or decrease it. If you decrease it, you're going to run into an exception because it's going to run out of gas just before it managed to deploy it. Gas price of 1 gigawatt is okay for me. Okay, so I'm creating a transaction now to broadcast and deploy the smart contract. And we're waiting for this one to get mined. Just because I don't like looking at that one, I'm just looking at this one here. You have some wheel moving. now, while we're waiting for that, just a short question. How do we get this smart contract address actually? The smart contract address is actually generated in a very interesting way. It basically depends on your sending address and on the nonce of this account. And these two pieces make sure that a smart contract address is unique. And it also means that you know the address of a smart contract ahead of time. Right? So you could predict what is the address of the next smart contract you're going to deploy. And there's a very funny thing that you can do with it. You can basically hide money in a not yet existing smart contract. So you can send money to an address that looks like an externally owned account because there's no code behind it. It's holding this money now. Then you actually broadcast a smart contract with the right nonce. Like you have one shot to get it right? If you fuck that up because there's some out of gas or something, that's gone. Then you have a smart contract that exists and can use that money. It's kind of very weird. Yeah, and other people don't know that this is actually going to be a smart contract at some point. All right. So what we have now here is we have our smart contract, and it's on the Robster network. And what I can do now in Remix is I can use these values. I can, for example, set a value to hello BIOTS. So I want to submit this thing here and broadcast it. So now what I'm going to do is I will copy this address, and I'll put it on Slack. I'll put it on Slack. This is my address. And what you can do now is that you can actually interface my smart contract. Try not to write embarrassing things into it, please. So what you can do is, you have to have the same version of the smart contract, right? So it has to be like the ABI specifically has to match, right? So the ABI has to match, and then you can click, instead of clicking create, you can paste this address in here. So if, for example, I had to, I accidentally killed it, or I had to reboot it again, I can just tell it to load it from this address. And yeah, this is not, let's reload it. So I see one transaction that came in here. I see also that the function setGreeting has been called. I see the method ID, which is, as I said yesterday, the hash of the function name and the type. And I see the ASCII, the hex encoded values here. All right, so now let's get back to Remix, which seems a bit quirky today. This is a little bit slow. Okay, but basically what you can do is you can read these values either through Remix or some other means. So if you don't have a UI for your smart contracts, there's always one fallback that I wanted to show you. So we have a tool called MyEtherWallet. Recently, there has been some dispute between the two people behind MyEtherWallet, so now we have this MyCrypto and MyEtherWallet. It's the same thing for now. So what we're going to do here is, first of all, what we have in here, we have the network that we're connected to. So just like in MetaMask, I can choose the network. And I want to connect to the Robster network. So there's different providers here. You can also provide your custom node. So MyEtherWallet isn't a bank. We know that now. So what I would like to do is, okay, it seems maybe a firewall issue. So what I'm going to do now is I interface my contract through this interface here. So I basically just tell it the contract address. So that's what I just pasted on the Slack for you. And the second thing I need is I need to paste the ABI. So you can either take the ABI from the custom.js file, or I take the one that I actually have compiled here in my ABI. No, this is actually string encoded, so that doesn't work. That's a bit annoying. Okay, so I'll take it from my custom.js file. Without the semicolon. I access the smart contract, and I do the get greeting. Yeah, we seem to have a bit of a firewall issue here. Okay, I'll try to connect to my phone's hotspot. All right, so basically what I wanted to show you is that you have through MyEtherWallet or mycrypto.com, you have a way of interfacing a smart contract. Again, you need the address and you need the ABI. You have a drop-down function down here for the getter functions and for the setter functions. If you have a setter function, you of course need to provide it a means of signing the transaction. So there's different ways how you can make that happen. The easiest is of course through MetaMask. So if you do that, it's taking the injected Web3 object and using that for signing transactions. What you can also do is if you have a lot of money or some really, really important function here, you connect it to a hardware wallet, for example, digital bitbox, and connect it like through the digital bitbox to MyEtherWallet, MyCrypto. So I will connect to, MetaMask. And I'll write to it. So this one here, unfortunately, doesn't have a really working gas estimation, so I'll be generous and give it 500,000 gas, just because it's not real money and this thing shouldn't fail anyway. Yeah, okay, and now we don't get it out. I'll connect to a different Wi-Fi. Okay. If we look at the smart contract address, oh, we see that some people were sending something to it. Good. So it seemed to work for some of you. I will try to read again from my remix and read the value. Does it work for somebody here? Yeah? Okay, good. At least for some people it seems to work. So again, I'm going to connect to this smart contract. Yes, okay. Yes, okay, so somebody likes garlic bread. Good. Yeah, so this works. We can interface the same smart contract from different machines, like through the actual blockchain that's running, that we are all individually interfacing through MyEtherWallet. Okay, happy to see this working so far. Let me try again to go through MyEtherWallet. I'll paste it again. No. Okay, so it doesn't work for me through MyEtherWallet here. All right, the next thing that I would like to do with you is to interface that really and access it through JavaScript. So we will take this. You can take your smart contract, you can take mine. It doesn't really matter which way you go. And we put this into a web interface. So what I would like to do for that is you take your version of your smart contract and you can exchange it here. So I'm just copying my address in here. Make sure to put it in a string. The ABI should not have changed, but if you change the smart contract, never forget you have to update the ABI, okay? If you change some more version of it, otherwise it will just read some garbage back to you. Okay, and mark that this is actually in the Robson testnet. And since this is pretty much all that I changed, what I'm going to do now is I will first test this in the current version, which is on the RingB testnet. So switch over here to the RingB testnet. And what we have in here is hello world. And I will just change this to hello BIOTS. Now I'm being asked to sign a transaction here. So this costs 50,000 gas because I sent this data which is being written into storage. So per 32 bytes that are being written to storage, you pay 20,000 gas. So it's pretty pricey. And if you write a lot of data, it's very expensive. We'll get back to that later in some alternatives and how we can handle that instead of writing all that large data onto a blockchain. So, okay, I submitted this transaction, and we can check the original smart contract address on the RingB testnet. Was this address? And if you go to ringb.etherscan.io address and paste the address, we see one pending transactions, and after this transaction has been included, we should be able to read it back. So if there's many of you currently on the RingB testnet, we are probably filling some blocks here, and that's why I have to wait. So this is 50,000 gas. 50,000 gas means that we can, I think in RingB we have a block gas limit of around 6 million. So you can put something around 120 transactions per block. Good. Okay, this one has been mined. And the contract got some data. Let me read it back. So hello BIOTS. It did work. We have a complete, basically end-to-end test. We first wrote to it, and then we read from it. So you can use pretty much exactly the same method if you have some of your own functions and you want to render it in a web UI. You can get started with this and can display some values on it. So one thing that's why I said yesterday, try to keep it simple at first. All these requests are asynchronous. So you have all these callbacks. So you might end up in this callback hell where we have one callback calling another callback. It looks really ugly. For the ones that are a bit more advanced in JavaScript, there's an async library that makes your life a little bit easier in having all these nested callbacks. Good. So you can also use that then for returning multiple values. So if you look at the code that I have here, if you look at my custom JS file in my getter function. So in my getGreeting function, I'm only getting back one value. You can, of course, also have a function that has multiple return values. In Solidity, so far you cannot return arrays. So if you have, and this is a typical limitation that people face in smart contract development, just because the EVM, the Ethereum virtual machine, as well as Solidity is still kind of limited, you have to get these elements in an array one by one. So first you have to read the length of an array, and then you have to query them one by one. So there's unfortunately no nicer way really around that. But you can return, for example, a struct. If you return a struct, it will get you an array in JavaScript, and you have to access these array elements and build a complex type out of it in JavaScript again. Okay. The next thing I would like to show you is our to put the actual RingB address in here and how you can build a user interface without having to worry about a web server. So if you have GitHub accounts, there's something called GitHub Pages. And what GitHub Pages really is like a web server for you where you can host content and access it. So the limitation with MetaMask is that you cannot run this locally. So if you have a local file, then this Web3 object doesn't get injected. And there's security reasons behind that. So what you have to do is, if you want to write your own web interface and utilize MetaMask, you have to host it somewhere. If you have a web server, I think ETH still has these like student websites where you can host stuff. This works. Maybe that's easy. And one other way is to go through GitHub pages. And what you can do is you can go on this repository and you have to fork it. So you can click on this fork button and put it in your own under your own personal name. And this one then you can make available under your own name as a GitHub page. So just click on that fork button, and I would have to choose the organizations under which I put it. And yeah, and then if you go to settings, so after you fork that repository and you go in your own repository, you scroll down, there's a section called GitHub Pages. You will just publish the master branch as it is, and it creates a URL which is something like this one here. So sometimes it takes a few minutes until it's updated, but this is one easy way of how you can edit it. So what you can do is, if you don't want to have any IDE, so have things really, really simple, you don't want to install Visual Studio Code, that's also okay. You can go to this repository, to your version of that repository, because you probably don't have write access here. And you can edit this custom.js file. So what I'm going to do now is, I'm going to change the address. I'm going to change the address here. And this is the Robson testnet. And you can commit these changes. And that's one way how you can very easily put your own content up there. So now it might take a bit until this one is reflected in the website, but basically this one gets directly, as soon as you push it, as you commit these changes, they will get, after some minutes, reflected in GitHub Pages. Yeah, so this is an easy way of how you can interface things with Web3, how you can read and write from a blockchain. If you want some documentation on what you can do with Web3, there's a whole documentation that I will share later on Slack for doing more complex things. Take into account that you are operating on big numbers, and take into account that we work in this asynchronous world. I'm working here with an older version of Web3. There's a beta, there's a 1.0 beta. I'm not working with this one yet. This one is working with promises. You can also use it with async await. And this older version doesn't yet work with promises, it works with callbacks. That's the syntax that I demonstrated here. Might be a bit more accessible to people that are not used to the JavaScript stack. The next thing which I got some questions for is unrelated to this specific example. Isn't it actually really expensive to write data into the blockchain, or what if this data is not available anymore, or I don't want this data to be available anymore, and so on. So it's quite a typical discussion that we have with many people. So because Validity Labs builds decentralized applications for clients and really tries to build some decentralized technology out there for very different use cases. And many times people that don't really grasp this whole blockchain concept in its entirety are struggling with this notion of blockchain is a database, right? Yes, blockchain is a database, and you have all your SQLs, your NoSQL databases that are, you just shove tons of data into that. This is not what blockchain is meant for. You can, of course, write like a decentralized Facebook and start from this example. Instead of just showing one message, you take the message board example that we had yesterday in the Solidity session and build like a fancy web UI around it. That's like a naive implementation, and it works. But it will be pretty expensive, because as soon as you start uploading data like images, it gets really, really pricey. So for example, we've seen that we pay 20,000 gas per 32 bytes. So multiply that with 1 gigabyte, and then multiply it with the size of the image divided by 32 bytes. You'll find out it's probably going to cost you a few $100s to upload one image. So that's not exactly a way to go. So how do you do that? Well, you could simply say, I host this picture on some centralized server. like on some of these picture upload services, and pull in the URL and only add the URL into the smart contract. They'll be relying on centralized services. For decentralized applications, there's more than just blockchain. So blockchain is used for transactional data, for financial interactions, everything that has like a transaction nature, everything that you want notarized and later on be available for notarization services, such as dispute resolutions. Did I have access to this information like 1 year in the past, yes or no, and you can prove that. For sharing the actual data, blockchain is very expensive. There's another piece of technology that I would just like to very briefly demonstrate. It's called IPFS. It's the Interplanetary File System. And what IPFS does is it's really like a data layer. It's a decentralized data layer that we can use like pretty much like a file system. So you can basically download an IPFS client, and it doesn't take like hours to sync and so on ipfs.io. So if you go on ipfs.io, you can click on try it. You click on install IPFS now, download IPFS for your platform. And I downloaded the 64-bit version of it. Now I have this already installed, so it downloads it downloads basically an install file that I installed from my command line via source install. And what I have here is I have IPFS now installed on my command line. And what you can do now is that you can, this is like this global file system, and you can add files to it. So what I'm going to do now is I'm going to create a file, and just to keep it simple and debuggable via command line, I'm not going to upload pictures, I'm just going to upload a short text. So I'm this thing, and I will put it into a test text file. Okay, so you can read that again. So we have a short text. This could be like, imagine this was an image that is really, really big. It's just a bit harder to debug. So what I'm going to do now is I have an IPFS client that I have installed here. So I am going to add this file IPFS add test.txt. Well, okay. IPFS init. Yes. IPFS add test.txt. So what this did now is IPFS is a content addressed system. So content addressed means this is a hash, it's a multi-hash, which represents the underlying value that's inside that file. So it's a means of making sure that if 1 bit of this file was modified, this hash will totally change. So you can be sure that the data that I shared with you is actually in the very version that I showed to you. So this ties into some of the other things that you have heard from Martin Gottwald and from Akasha yesterday. So have you seen a demo yesterday of IPFS? No? Okay, good. So I basically added this to this IPFS, global IPFS file system, and I'm just making sure that this file is actually there. So I do an IPFS cat and see actually, okay, this thing is there. Now, what I'm going to do is I run an IPFS daemon. So what this daemon does, it connects to this IPFS network of like nodes that basically forward files. And I'm taking this hash now, and where was my hash? Cached here. And what I'm going to do is I go to an IPFS gateway. So I'm going to this IPFS gateway and pass this hash in here. So it's a little bit slow. And what we can do in this way is that you can share data and share files which are actually being broadcasted through the IPFS network, which is a decentralized file system. And into your smart contract, you only write this IPFS hash, which happens to actually be 32 bytes. So in this way, you can limit the amount of money that you pay per transaction and just have a hash of the data that is made available. You could even say, hey, I actually don't really feel like sharing this data at all, because I just want to prove that I had ownership of this data at some point in the past. So for example, you want to prove that you were in possession of a specific piece of information, like, I don't know, a proof that, that proves that you invented something, right? So this proof that you invented something, you don't need to share to the whole world through IPFS, but you hash it, and you commit this hash onto the blockchain. Like, this is super simple. You don't even need any sort of actual smart contract for it. You just have like a pretty much 3-line smart contract that just logs something and acknowledges that it accepted it on the blockchain. You could, of course, also then make like a content registry service around it in a very simple way. And you can share arbitrary pieces of information in there, but just having the hash on there. And later on, if there is some dispute and you have to prove to a court, for example, that you were the first to invent this specific thing, right? Then you could prove that this was A, written on the blockchain, so that's the notary service, and B, you had access to this file and reproduced the hash. So you have a proof that you were in possession of that. I'm not saying that that might necessarily stand the requirements of courts, but this is, like, technically speaking, a solid way of proving possession of ownership or of IP or of a project in the past.
How come you store data for free?
Yeah, how come you can store data for free? It's not exactly for free. There's no free lunch, right? So I have in here, I have now my daemon running. And, oh, this worked, finally. So I have my daemon running, and this gateway, it's really just a convenient way for you to access it. What I'm actually going to do is, this is of course centralized, right? So you right now have to trust that gateway.ipfs.io is really serving you the content that's behind that. You could verify it, of course, with recalculating the hash. But what you guys can do is I will paste this hash actually also in Slack. And what you can do is you can simply take the same thing and do IPFS cat, right? So you can do IPFS cat and then this. So this thing is going to work as long and exactly as long as my daemon is running, unless it's still in cache somewhere. So you can also say, hey, this content is really valuable to me. I keep it in storage at my premises, right? So you can do an IPFS pin on this hash to keep it there. And this is not for free. It's a means of accessing this data in a peer-to-peer fashion. It's not necessarily a free storage system. There's a related project which is called Filecoin, which provides an incentive layer for you to actually serve this data and keep it available, potentially also to keep it available at like some guaranteed uptime or latency and some other features. Other questions? Yeah?
So it's kind of a CDN, so content delivery network that caches it?
So it doesn't really cache it unless it's being used. For example, right now, if you were to, if I take my, and this really depends on the configuration of the IPFS node. So currently this information is available, and it's actually available pretty efficiently. So you can actually stream videos and stuff over this. So what I can do now is if I take my daemon down, I killed it. This thing is still available because these nodes are nice enough to keep it in cache because there was some demand for it in the past. But there's no kind of, this was kind of what this previous question was aiming at. There's no free lunch, right? So there's no guarantee that this thing happens to be online unless you add it. So you can do IPFS pin this thing to keep it around in your storage, at least for you.
I'm not sure, have you heard about, I think it's called
StoreJ, yeah, yeah. There's a bunch of different ideas around. So there's StoreJ, there's MadeSafe, and a bunch of other things. It's basically, I would say, IPFS, in my impression, is that IPFS is the most solid behind the scenes, most academic between all these different approaches. So StoreJ and MadeSafe are also different systems that also had like some tokens that is around to incentivize people to actually provide your disk space and make it available for other people to use. IPFS is going beyond that by really doing a lot of really heavy core infrastructure development behind the scenes. For example, incentivation. For example, by providing APIs. So they have by now actually a full JavaScript implementation of their entire client. Right? So you can run this entire thing in JavaScript, which is actually quite cool. Have all sorts of tunneling infrastructure. So it's not very opinionated on what it actually runs on. That's one difference here. But generally, so if you have large data, this is a good way to go about it. So just like you had these Web3.js JavaScript library, there's an IPFS JavaScript wrapper or an IPFS JavaScript implementation that you can use to access data that you have in IPFS. So you would use blockchain kind of as a pointer layer. So you have like an indexing that's done on the blockchain. You might also have an incentivation that's done on the blockchain. And then this blockchain is pointing, and the pointer is like an IPFS multi-hash starting with this Q something. And this thing is actually then the storage layer. So this storage layer of IPFS or some related projects like StoreJ, or there's others that also the Ethereum Foundation is pushing, which is Whisper, which is kind of peer-to-peer messaging, or Swarm, which goes in a similar direction as IPFS. More questions?
So for a real application, I need to provide the content myself, or pay someone.
So what? If you want to build something through IPFS, it's a question kind of what is this content? Like, do you want users to self-host it? Like, the nice thing is you could build an application that runs on zero infrastructure. You could have your IPFS including actually, and this I find interesting, the front end. You could have your front end being exclusively served through IPFS. So you could either do this through this gateway, or actually when you start the daemon, if you start the daemon, it is actually providing you some local interface that you find in there, so that you can run through. So you have an interface which is served through IPFS, which means I didn't mess with any content, because user interface manipulation is really severe, right? What if I were to make like a payment site? And in this payment site, actually, I did only one change, and that's the address. We see this with many of these ICOs right now. There's one interest that people have. Well, they have an incentive to change the payment recipient address. So if I can manipulate that in the front end, it's pretty bad. So you could serve your front end through it, and this you might want to serve, right? You have a daemon centrally running. But then you could give people the choice of serving their own content and being themselves in control of making that available. For now, we don't really have working incentivation methods yet, such that you say, hey, I pay some of these file coins, for example, for having a certain reliability or a certain, I can be relatively certain that this thing is actually online. Any more questions? Good. Then I think we can stop here for lunch. And I'm around here if you have some more questions offline. And one thing that I would like to mention is Validity Labs is also hiring. We're looking for curious people that are working with us, either be it a master thesis or an implementation project or project management. Like, we're open to all sorts of things. Come talk to me or Andre in the breaks. Thank you very much.
Okay, yeah, then it's lunchtime again. We'll meet at 1 p.m. sharp again here in this room. Please also, a reminder, we had some capacity issues with the Wi-Fi So please switch off all devices that you don't need during classes. That could maybe help. Thank you very much. See you later.
So I'm really curious about this interaction with the web interface. What's the trajectory?